Hi everyone. Today we're going to talk about spokeshaves and on the way to modifying and improving a modern spokeshave. All right, so the name of a spokeshave is kind of self-explanatory. It's often used to round over a chunk of wood into a dowel for the use in a spoked wheel or a spinning wheel, or a lot of chairs have round tapered spokes, and those are usually made with a spoke shave. And of course, they can come flat or curved in a variety of different styles. Sometimes you'll get one tool with a flat blade and a curved blade right next to each other, so you don't even have to pick up another tool to change horses. And then here's some examples of wooden ones. These are really elemental. One piece of wood for the handle. This is beech, I believe. And I'm not exactly sure what this one is. This one's beech, and it's got, a forged blade that a blacksmith would make. And then you carefully drill holes and cut mortises so that it wedges in there and stays put where you want it. So you'd have to, drive this in with a little mallet and play around until you got it to the blade to protrude the right amount for the cut you want. Pretty clever thing, elemental woodworking tool. So this is a knife and a holder we're calling a spoke shave. This one I've already shown you if anybody's looked at my bracing film. This is the tool that I prefer to cut the braces on the archtop. Lovely little lightweight tool. And you can see on this one, I added a piece of material. This is a piece of G10, which is a fiberglass and epoxy resin, very tough material, piece of G10 plastic that I inlaid in here, and which has given good service, resisting the wear. And then here is another version. This one's a little fancier. It's got inlaid nuts here on the top surface, and you can see these little thumb screws so that the ends of the blade are threaded, and these thumb screws can adjust the depth of cut. And you can see also on this tool there was a brass throat that was originally inlaid in part of the tool at the very outset. Again, a lovely woodworking tool from long ago. Cool piece of gear. All right, so next, a lot of things got made in cast iron. Gray iron was used to make almost every kind of tool at some point or other. These are both Bailey tools, and they're both interesting and clever in their own right. Here's a blade that has no features aside from the bevel. This tool has a couple of cool little slots in it, which you can see there. And then the clamp fits in those slots, and a little screw sticks it all together and holds it firm while you're using the tool. Lovely tool, nice and light, kind of svelte handles, really nice tool. And this is a same manufacturer, Bailey. These are both from the 19th century. This one has a captive clamp with a pin that captures it at each end. And then there's not only is there a blade, much the same as this other one we just looked at, but there's also a chip breaker. Now, a chip breaker is a tool that, part of a tool that makes what we'll call a double iron. So instead of just having a single blade, we have the blade, and then it's supported by the chip breaker. And as its name suggests, the idea is that when a shaving that's being removed from the surface of your work comes up here, it bumps into this curved surface, and instead of being a stringy thing with a mind of its own, it gets broken by this surface, so it gets cracked, and it turns into a curl. And so when you see curls coming off of a plane, a lot of times it's because it has a double iron, and that the top of that two-piece assembly is a chip breaker. Okay. And then here is a Stanley tool. Again, this is an old tool. Could be 19th century. It sure looks like it is. You can see I straightened out the bottom on this tool. This is a very simple tool, and this has a more normal kind of clamp. This is what we're used to now. Here you can see there's little sockets in here. These don't have a function except in the foundry, where it's better to have a casting that doesn't have abrupt, thick areas, because they tend to distort and cause problems. So in this case, they took these two little chunks out of the material. Does a couple of things. One is it keeps the tool light so that it's fun to use, doesn't weigh too much. And then the other thing is, of course, it preserves the material in the center for this screw to address, right? Anyway, kind of a cool tool. These tools are a little bit fussy, all of them that we've talked about so far. A little bit fussy to adjust for depth, except of course for this one, which has its own little mechanical adjusters. But the rest of these tools that we've looked at are a little fussy to adjust for depth. Here is a modern tool by Veritas, good company, and you can see that they've combined several elements. They've got a very simple kind of blade that is retained by these clever little clamps. Right here you can see they have a little half a dovetail shape in there, and then there's a half dovetail shape on the end of the blade. So what it means is that unlike these blades, which are really pretty tricky to sharpen because the unusual and complicated shape of the blade, this kind of blade that Veritas has provided is very simple to sharpen, same way you'd sharpen any knife or plane blade. The additional feature on this tool is the cutting depth adjustment happens by this plastic part being adjustable up and down. So kind of an interesting take on it. As you can see, I have used this, and I have to say that I didn't find it a terribly great tool, but it was thoughtfully made and they had some good ideas. All right, now, later on, the Stanley Company came out with these. This is a number 52. Oh, this one's a number 51. That's a 52. And this one is a number 151. So I'm not really sure what the difference is in these tools. Obviously the handles have some differences. This one's lower. Anyway, I'm not sure what all the numbers mean. Having said all of that, this is the one that I prefer, and this is the one that we're going to hot rod and modify. And that's the modern 151. So it's the same, it's got the same number on it as this one. They both say number 151. But this one, more modern one, has these nice landing surfaces here, these little concave surfaces to put your thumbs on. And I think this makes the tool a lot more fun to use than this pattern without those. All right, so we're going to set these old big guys aside. I made this jig in order to play around with these Spokeshaves in here in my shop, and you can see on a bunch of these tools that already have a piece of brass or soldered in. And then here's one that's actually assembled and seen some work. So you flatten the surface, you add a little piece of material in front of the blade so that you can get the throat opening the correct size, which should be almost nothing. And then you've got a nice tool that'll work better than it did when it was brand new. All right, so let's see. We'll look at blades here for a minute. These are blades that all fit these tools we're looking at. Here's a blade. This blade I think I bought new in 1974, and I've been using it in this tool up until recently. And you can see how much has been cut away and started out like that. These blades are from Stanley or Record. They're, I think, between 57 thousandths and 68 thousandths thick. I'm not sure if that's intentional or what happened, but here's one. This is the smallest one, 57 thousandths or 1.45 millimeters. And this is 62 thousandths or 1.58 millimeters. Anyway, there's a little variation, but they're roughly 1.5 millimeters or 1/16 of an inch thick. And then these are modern blades designed to fit the same tools. Here's one that's made by Hawk. This one is 0.94. It's 94 thousandths, so that's 3/32. And this is, the same thickness, 1,000th of an inch different, but it's still, the idea is that it's 3/32 or 0.93, and in metric measurement 2.36. So obviously these are quite a bit thicker than the original supplied irons, and what it does is it gives us an interesting choice. So if we make the Spokeshave blade opening so that it will take this cutter, this thick cutter. All right. See, these aren't helping me. This is the one we're going to actually do the operation on. This one is as yet unmodified. And you can see this one is called an A151. Again, I have no idea what that means or why it's not just a 151. And it has, these nice little concavities that we can lean on with our thumbs. So, finish my thought. I was going to mention that I think you can see that there's a pretty big throat opening here. A little hard to see. Well, anyway, it's bigger, much bigger than you would ever want. But if we make the throat opening correct for this thicker blade at 3/32 of an inch, then we could also employ a thinner blade and use it for a coarser cut and get a lot more room for the chips, if that's something that we thought was interesting. So we're going to use these blades, which are higher quality. They're super flat. They're beautifully made. These are Veritas blades. You can feel how flat these are. It's just They're just really, really nicely made. And not to be critical, but this hawk blade, we can see that this is stamped, and the stamping quality is not fantastic. So these are a little distorted here, and the blade is not particularly flat. And so it'll be more fun to use these Veritas blades because they're perfectly flat. Now, since I was just talking about stamping, let's look at the final part of this system. So here's an old cap, and that would probably be the same kind of cap in here. Let's just see what this looks like. Yes, sure enough. So you can see that these are sand castings, and this one says B. These are casting marks. This has some other numbers on it. That's for the people to keep track of in the foundry. And these have, I believe, these are designed to have a little hollow. These are not perfectly flat on their back. This one even more so has quite a pronounced hollow in the back. And that's to help the clamp, put the emphasis of clamping right down here where we care about it. Okay, so this is a refinement which was lost when Stanley and Record started using a punch press to cut these parts out of plate steel. So whereas these are cast iron, these are plate steel. They're the same thickness everywhere, unlike these lovely castings. They are kind of deformed. You can see how the edge of the part is rolled off in this direction. And so right here, the business end of the tool, where, as we pointed out on this tool, the surface is cleverly curved so that the pressure of this part is applied right at the edge of the tool. And this one, because of the kind of low quality way that they made it, curves in exactly the opposite direction that you would prefer. Now, when I started playing around with these things, for some reason I thought it would be a good idea to make some out of bronze. So I made my own caps out of bronze, which you can see. Here's one employed on a tool. You can make it the right width so it doesn't wiggle around, and you can get it to be exactly the shape and size you want so that it grabs the plane blade right down to the end where it should. Okay? One final thing is, I don't know how much you might know about threads. These are not metric threads. Okay? These are wire gauge threads from the 19th century, and it's a funny system. I'm not going to bother trying to explain it. You can look it up if you don't know and you want to know. But these are a size that is very uncommon these days, used to be widely employed. These are a number 12. So it's in between a number 10, which is 3/16 of an inch, or just under 5 millimeters, and it's smaller than 1/4 of an inch, which is, I don't know, 6.3 or something like 6.3 millimeters. So it's a funny in-between size that just doesn't seem to be used anymore. Yet here they are on all the Stanley and Record spokeshaves. These two studs are threaded number 12, 28 pitch per inch, and then this screw in the center, the hold down, is threaded number 12, 24 threads per inch. So these are two different pitches. This is a fine thread for adjusting, and this is a coarse thread for strength. So I think that kind of takes care of the bits and pieces. And you can see that I thought it might be a good idea to have the right taps and dies, so I went ahead and bought these. They're not expensive. And that way you can chase, if you have little problems in the quality of the threads here or there, you can either chase these long threads, or chase the hole with a tap to make sure that things run nicely. All right, so our job, what we're going to do next, is we're going to take this tool and make it into a tool like this. Now, this is a tool that I first modified in 1974. I've used it on every guitar I've ever made. It's been a real workhorse, and I don't know, some years ago I decided to treat it to a smaller throat opening, so I put it on my milling machine, I think in this fixture that I built for that, so that I could put the spokeshave in here and grab it. Not a great way to grab it, but it was the best I could figure out. It's hard to grab castings because they distort and they're not exactly precise parts. Anyway, grab it here close enough. I was able to go in there and cut this surface with a milling machine, and then with a funny little saw, get in here and slot the brass chunk that I soldered in there and make it the correct size for the modern thickness. And you can see that there's a very, very, very small distance in between the blade and the slot. It's the same, exactly the same all the way across. And what that means is that when you're using the tool in wood, this piece of material right in front of the blade is able to hold the wood down as you press on the tool. You hold the tool down tight to the material. It pushes down on the wood and helps to support it right before it gets cut. And that helps the cutter do a great job and results in a better quality surface with less tear out. And of course, especially as we approach final thickness in archtop guitar making, tear out can be a catastrophe if we don't have control over it. So what I'll do here in front of you next session is, without using the milling machine, take this casting and clean up this surface with files and scrapers. Then we're going to solder in a little piece of brass material in such a way that it'll be easy for us to get this nice condition, a parallel throat with no more throat opening than we absolutely need to pass a shaving through. And it's going to transform the ability of the tool to do a terrific job. So that's our hot rod Spokeshave. These are available used on eBay for about $25 in perfectly good condition. And then these Veritas irons are, I forget now exactly, but about the same price for 50 bucks. And a little bit of fooling around with a file and a torch, you're going to be able to create a world-class tool that'll really help you take a beautiful shaving on the inside and outside sometimes of your archtop guitar plates. That's the scoop. Thanks for watching.